Okay, so our third case here that we're going to cover is the one with irreducible or quadratic factors. So that would look like something that we have here, where we have ax squared plus bx plus c, where this cannot be factored any further, right? And what that means, if we think of the quadratic formula, b squared minus 4ac, right? This quantity here is going to be less than 0, right? Meaning there are imaginary roots here, but here we're dealing with the real numbers, so it will not, it is what we call irreducible. And as it turns out, every polynomial can actually be written in factored form into a product of irreducible, at least quadratic terms. Okay, now how we're going to approach this problem is here. Let's take a look at this example. So I have the integral 2x squared minus x plus 4 over x cubed plus 4x dx. Okay, now here again, just double check that the degree in the denominator, which is 3, is bigger than the degree in the numerator. So it is. And now let's factor the denominator. Okay, and now what we see here in the denominator, we have a linear factor in the x, and then an irreducible quadratic form. This cannot be factored any further, right? It's not x squared minus 4, because that would be a difference of squares, and I could factor into a pair of linear factors. But now x squared plus 4, it is irreducible. So it is a quadratic factor. That is about it's as factored as it can get. Okay, so our setup here is 2x squared minus x plus 4 over x squared plus 4. And the decomposition of partial fractions will look like this. We have a linear term that's not repeating, so that corresponds with the constant a over x. And then our quadratic term will be put above some kind of linear expression, bx plus c. Okay, so now it's time to solve for a, b, and c. So again, this process is the same as before, where we start by multiplying through by the common denominator, which is x times x squared plus 4. If I multiply through on the left, I'm left with 2x squared minus x plus 4. And on the right, we have a x squared plus 4. And then here we have plus bx plus c times x. Okay. All right. And then we'll start by plugging in. Here there's only one root, so that root being 0. So I'll start by letting x equal to 0. Okay, so if I let x equal to 0, on the left I get 4, and on the right I get 4a, and then this quantity goes to 0. So I get a is equal to 1. Okay. All right. And now for b and c, what I'll do is actually I'm going to compare coefficients, right? So since a is 1, I'm left with x squared plus 4. I'll distribute this x here, so I get plus bx squared plus cx. All right, and then one thing I notice here is that our 4's will cancel out, right, which makes sense here. So we get, actually, let me go back here. Okay, so let's just group. Let's not cancel out. Let's not cancel out anything. Let's just group our like terms here. So the x squared is going to factor out an x squared, so we get 1 plus b, x squared plus cx plus 4. Okay, and then from here, comparing coefficients, right, we have 4 and 4, that's good, right? The constant is 4. I get c has to be -1 by comparing it here. And then I also know that 1 plus b must equal to 2. In other words, b must be 1. Okay, so now I have my integral. All right, the integral turns out to be, so the integral of 2x squared minus x plus 4 over x squared plus 4 dx turns out to be a over x, which a we said was 1, right? So the integral 1 over x plus b, which is 1, so x minus 1 over x squared plus 4 dx. Okay, now the first one is straightforward, right? The natural log. Now, what to do about the second term, right? Now, here what I'm going to do is, since I do have a expression of x minus 1 in the denominator, in the numerator, excuse me, I'm going to split it. I'm going to rewrite this as this. All right. And now I do have at least 2 natural log integrals, right? 1 over x, the basic form of natural log. Now here, right, through a u substitution, right, if you let u equal to x squared plus 4, du is 2x dx, right? And I have the x here. The only thing missing is the 2, so I'll divide it out. And it's 1 over u type, so that's natural log of x squared plus 4. All right, now this last term here is not a natural log, right? Because the x squared, the derivative of x squared plus 4 is 2x. I don't see the x up here, but it is a tangent inverse, right? It is one of our trig, inverse trig integrals. So this is, right, where it's x squared plus a squared, a being 2, so 1 over a, 1/2, tangent inverse of x over 2. And of course, plus c. Okay, and that's how we can deal with our quadratic factors.